All right, so here we are back for part 2 of chapter 6 of the Hurley book. We're going to be looking primarily at 6.4 and 6.6 in this one. 6.4 being the most important for us right now because that is where we learn how to determine whether an argument is valid or invalid using the truth table method. So in the first video, I did go through the 5 truth tables for you. Make sure that you have those written out and sitting in front of you before we attempt to do the work for this section. Basically, what you learned in 6.2 dealt with individual sentences. Well, now we're going to look not at sentences, but at arguments, and we'll be able to see that the same basic technique that's used in determining the truth value of a sentence can be used for determining the truth value of an argument using the truth table method. So, let us take a simple argument here, and we'll say if this pen doesn't seem to want to work right now, so let's switch to another one here. All right. So if A, then B, not A, therefore not B. Okay. So I want to know, is this argument valid or invalid? The way I'm going to do that is to construct a truth table for it. The first thing to do to construct a truth table is to look at what sentence letters you have. Remember, as I said last time, the number of sentence letters you have determines the number of lines on your truth table. In this particular case, we have 2 sentence letters, A and B, which means that there will be 4 lines to your truth table. A and B could both be true. A could be true, B could be false. A could be false, B could be true, or A and B could both be false. Now, once you have that set up, those are your 4 possible scenarios, what we're going to do is take our argument and write it out on the line over here. The important thing to remember, of course, is that what you have are 3 statements that are being made, your first premise, second premise, your conclusion. So in this case, we have if A, then B. That's the first premise. Now, your book doesn't tell you to do this, but I find it useful to draw a line to separate those because there's a tendency among some students to try to solve this once it's written up here like one big long equation, and it's not. It's 3 individual sentences. So your first sentence is if A, then B. Your second is not A. And then your conclusion is not B. And I recommend putting a double line between the premises and the conclusion, just so that the conclusion stands out. Well, now what we want to do is use the information here and solve for each line. So, if I look at the first premise, I have if A, then B. That's basically a conditional statement. So, using the conditional chart, if I have a line where A and B are both true, true, true with the arrow is going to be true. Looking at the conditional chart, the antecedent is true, the consequent is false, true, false with the arrow works out as false. The antecedent is false, consequent is true, false, true with the arrow is true. And on the last line, A and B are both false, false, false with the arrow is true. So it's just the same thing that you were doing with 6.2, except instead of somebody telling you A and B are true and C and D are false or whatever, you're seeing your truth values from the chart that you've worked out here, showing all the possible scenarios. So you've just dealt with premise 1. Let's move on to premise 2. Premise 2 is not A, so you're going to look at column A, forget about the B, just look at the A, and you're going to use your negation chart. So if A is true and you negate it, it becomes false. If A is true and you negate it, it becomes false. A is false, negated, it becomes true. A is false, negated, it becomes true. And now you've done that. Now we move on to the conclusion, which is not B. So we're going to look at the B column, forget about the A column. So on line 1, B is true, negate that, it becomes false. Line 2, B is false, negate that, it becomes true. Line 3, B is true, negate that, it becomes false. In line 4, B is false, negate that, it becomes true. Now, you've just completed a truth table. How do we decide whether it is valid or invalid? Well, think all the way back to chapter 1. What is it that makes an argument valid? What is it that makes an argument invalid, rather? True premises leading to a false conclusion. So, what you're going to do is check line by line and see if there is any line where all of the premises are true and the consequent, or the conclusion is false. If you do, then it's invalid. If you don't, then it's valid. So on line 1, I've got a true premise, false premise, that's fine. Here I've got on line 2, 2 false premises, that's fine. But line 3, there's true premises, false conclusion. So since I have true premises leading to a false conclusion, it makes the argument, or shows the argument to be invalid through the truth table method. And that's all there is to checking it. Your arguments might get a little wilder, a little longer, but that's basically all there is to it. If there is any line, there might be more than one, but if there's at least one line where all the premises are true and the consequent is false, it's invalid. If it does not have a line like that, then it's valid. So let's look at another one. Okay. And we'll try to keep it relatively simple again. Let's say we've got not B or C, not B and C, therefore, if B, then C. Okay? So not B or C, not B and C, therefore, if B, then C. So looking at this, I have two sentence letters, B and C. So that means, again, 4 lines. B and C could both be true. First true, second false. First false, second true. Or all false. First premise, not B or C. Second premise, not B and C. And the conclusion, if B, then C. All right. So you've got the basic idea as far as what needs to be done, but shortcuts are always useful. And you know that what you're looking for is any line with true premises leading to a false conclusion. You don't actually have to work out an entire truth table to tell whether something's valid or not. You only have to do it to the point that you figured it out. And so you're looking for true premises leading to a false conclusion. So it actually makes sense, instead of working out the whole truth table, start with the conclusion. In this case, if B, then C. So you're looking at your conditional chart. On line 1, B and C are both true. True, true, with the horseshoe or the arrow is going to be true. Line 2, B is true, C is false. True, false with the arrow works out as false. Line 3, B is false, C is true. False, true with the arrow works out as being true. And on the last line, false, 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 false with the arrow is true. Now, the thing is, since the only thing that makes it invalid are true premises leading to a false conclusion, if you have a true conclusion, you don't care what the premises are, because it's not going to show it as invalid. The only one that could show this to be invalid is line 2, so that's the only one you actually have to care about. So that's the only line we actually have to solve. So on line 2, B is true, C is false. B is true. Negate that true, it becomes false. C is false. False, false with the wedge is false. I can stop right there. Without going any further, I know that this argument is valid because there's no possibility that I can have a line where true premises lead to a false conclusion. Okay? So it cuts down on a lot of work for you if you solve the conclusion first, and then you know you only have to worry about the lines where you have a false conclusion, and then work those to see if you have all true premises leading to that false conclusion. If you don't, it's valid. If you do, then it's invalid. Okay. I'm going to work one more with you that is a little bit bigger because some of the ones that you'll be asked to work with are not just 2 sentence letters, but 3. 3 sentence letters mean an 8-line truth table as opposed to a 4. So I wanted to do this so you can at least get the basic setup for it. I mean, it's going to work the same way, but we're going to need to see what the 8 lines look like, and I will not ask you to do anything bigger than that. So you don't have to worry about 16 and 32 line truth tables. There's another technique we'll learn in the next chapter that's much easier for those types of arguments than the truth table method is. All right, so let's say I've got if B, then C and F. Not B or C, therefore not B or F. Okay, so if B, then C and F, not B or C, therefore not B or F. So we've got 3 sentence letters here, B, C, and F. And incidentally, I always do these in alphabetical order. It's not a specific rule. I just think it makes it easier, and it'll certainly make it easier if you do it that way when we go to check them. Now, with 3 sentence letters, that means there's 8 possibilities. We could have true, 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 false, true, false, true, true, false, 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 true, true, false, true, false, 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 true, or false, false, false. Okay, so make sure that you take the time to get those written down. Incidentally, a long time ago, I just sort of learned those and sort of second nature to write them out that way. A few years ago, I actually found out from a student something I never realized before, and it's pretty obvious now that I see it. But if you look at it, the first column, you have 4 trues, 4 falses. The second column, 2 trues, 2 false, 2 true, 2 false. And the fourth column, true, false, true, false, true, false, true, false. So maybe it'll make more sense for you guys if you sort of do it in the column rows rather than across the way I learned it. But either way, whatever works for you, that's the important thing. Okay. So our first premise, B, then C and F. Our second premise, not B or C. And our conclusion is not B or F. Okay. So we're going to solve this just like we did with a 4-line truth table. The truth values for each line are given to us right here. We'll start with the conclusion, which is not B or F. So I'm going to look just at the B and the F, forget about the C. True, true with the wedge is true. We negate that, it becomes false. Okay. Now, if you want to, you don't even have to work the whole column. You can notice that this is false, so let's go ahead and try one of these others and see if it's going to work out. Maybe we only have to do the first line. So here, the second premise, not B or C. So B is true, C is true. True, true with the wedge is true, but we negate that true, it becomes false. So line 1 we know is okay, we don't have to worry about that. Let's move on to line 2. Not B or F. So B is true, F is false. True, false with the wedge is true. Negate that, it becomes false. So there's another possibility. Here, not B or C. B is true, C is true. True, true with the wedge is true. Negate that, it becomes false. So we know that line 2 is good. Third line. B is true, F is true. True, true with the wedge is true. Negate that, it becomes false. So another false line. Not B or C. B is true, C is false. True, false with the wedge is true. Negate that, it becomes false. Okay, so we know that one's good. Line 4. B is true, F is false. True, false with the wedge is true. Negate that, it becomes false. And let's look here. B is true, C is false. True, false with the wedge is true. Negate that, it becomes false. Line 5. B is false, F is true. False, true with the wedge is true. Negate that, it becomes false. We look at line 5 here. B is false, C is true. False, true with the wedge is true. Negate that, it becomes false. So line 5 is good. Looks like we might have a valid argument here. Line 6. B is false, F is false. False, false with the wedge is false. Negate that, it becomes true. So that one's okay right there. Line 7, B is false, C is true. False, true with the wedge is going to be true. Negate that, it becomes false. And here, B is false, C is false. False, false with the wedge is false. Negate that, it becomes true. So here's a possibility. Double check that again. B or F. So B was false, F was true. False, true with the wedge is true. Negate that, it becomes false. B or C. False, false with the wedge is false. Negate that, it becomes true. So it comes down to this line. B is false, C is false, F is true. In the parentheses, false, true with the ampersand is false. So false, false with the arrow works out as being true. So even though we thought maybe we might have had a valid one here, we don't. Because at this point you can see there are true premises, all true premises leading to a false conclusion, which means that the argument here is invalid. Okay? And so that is the way that we would determine the truth values there for those. All right. So on we're around page 355, you will see exercise 6.4, section 2. And it's a series of arguments presented to you. So the first one is if K, then not K, therefore not K. All right. So I'm going to say, why don't you just try to solve these, working them as truth tables. We'll do the first 10. So how about 1 through 10 on those? Okay. So 6.4, section 2, numbers 1 through 10. And so basically you just want to construct a truth table for each one of those arguments and decide whether it's valid or invalid. All right, so that brings us to the last thing that we need to look at in this chapter, and that is 6.6, which introduces argument forms and fallacies. And this is actually something that's really probably a lot more important for the next chapters than it is for this one, but it's introduced here, so we'll go ahead and take a look at it. There are certain argument forms that are so common it just makes more sense to remember the forms or recognize the forms than to have to work out a truth table all the time to decide whether they're valid or not. And so we have in this chapter presented to us 6 valid and 2, or 6 or 8, but anyway, a few valid forms, and there's 2 invalid forms. And so let's just go ahead and we'll look at these. I'm going to start with the common valid forms. And the most common is what's called Modus Ponens. Okay. Modus Ponens, which you can abbreviate MP, takes the form if A, then B, A, therefore B. Anytime you see that basic form or structure, without ever working it out, you know that it's valid. Now, this is the way that your book presents it to you. Several years ago, I came up with another way of doing this using squares and circles. And so the modus ponens, it might help you to think of in terms of this. If square, then circle, square, therefore circle. Now, the reason for that is because when you see A and B, you have a tendency to think in terms of one singular letter. But when you see the squares and circles, it reminds you basically that anything you can fit in there, as long as this is the same as this, or this is the same as this, fits that basic form. So, for example, if I had an argument that looked like this, if A and B, then C or D, A and B, therefore C or D. Now with that argument, if I were to work that out on a truth table, you've got 4 sentence letters there. That'd be a 16-line truth table. However, here's the thing. If I look at my first statement here, the antecedent is A and B. I'm going to make that a square. And my consequent is C or D. I'm going to make that a circle. Well, the square is A and B. There's A and B again. Let's make that a square. And the circle is C or D. Well, there's C or D again. Let's make that a circle. So what do we really have here? If A, then B. If A, therefore B. square, then circle, square, therefore circle. Even though it looks bigger, even though it looks longer, this is still the modus ponens form. We can still recognize the form and see it as being valid. And again, this is a big part of what you're going to be doing in the next chapter, in Chapter 7 next week. So just keep that in mind, and that's why sometimes I think people find it easier to use the squares and circles technique that I show rather than just the A's and B's, because again, it could be a larger equation. The thing is, again, this has to be the same as this. This has to be the same as this in order for it to count. All right, but that is the most common valid form that we have. It's modus ponens, okay, which takes that basic form. All right. The second common valid form that we're introduced to is called Modus Tollens, which you can abbreviate as MT. And that takes the form if A, then B. Excuse me again. Hello, please. I keep forgetting about that. All right, so if A, then B, not B, therefore not A. Or if square, then circle, not circle, therefore not square. Okay, so anytime you see that basic format, it would be modus tollens, and you could know just by recognizing the form that it is a valid argument form. So that's modus tollens. There are two argument forms which are not very common, really, but they're extensions of the modus tollens and modus ponens, so they're included here. The extension of modus ponens is what's referred to as the constructive dilemma, which you can abbreviate as CD. The constructive dilemma says if A, then B, and if C, then D, A or C, therefore B or D. Okay. So the constructive dilemmas form if A, then B, and if C, then D. A or C, therefore B or D. Again, this form is always valid. And it's basically just two modus ponens stuck together. You can see initially here, if A, then B, A, therefore B. And you can also see another modus ponens, if C, then D, C, therefore D, right? If square, then circle, square, therefore circle. So that's the constructive dilemma form. And again, that one is always valid. You'll recognize it because you have two conditionals joined by the dot or the ampersand. The second premise will always be the two antecedents joined by a wedge, and the conclusion will always be the two consequents joined by a wedge. So the constructive dilemma is basically an extension of modus ponens. And then we have what's called a destructive dilemma, DD, which is if A, then B, and if C, then D, not B or not D, therefore not A or not C. Okay. And so the destructive dilemma is basically an extension of modus tollens. So you can kind of see your Modus Tollens forms here. If A, then B, not B, therefore not A. If C, then D, not D, therefore not C. Okay? So the destructive dilemma, just like the constructive dilemma, starts with two conditional statements joined by the dot or the ampersand. But in this case, just like the Modus Tollens form, you're going to have the negation of the consequent. So the negation of your two consequents joined by the wedge is the second premise, and the conclusion would be the negation of the two antecedents joined by the wedge. So those forms, again, extension of Modus Ponens, extension of Modus Tollens, those forms are always valid. Two other common forms that they give you in this section. We have a hypothetical syllogism, which you can abbreviate as HS. Hypothetical syllogism takes the form if A, then B, if B, then C, therefore if A, then C. Or if you prefer the squares and circles, if square, then circle, if circle, then triangle, therefore if square, then triangle. And again, I use the squares and circles for the same reason here as we did before, because these could be much larger equations. The important thing is to notice that what is in this spot is identical to what's in this spot. What is in this spot is identical to what's in that one. What's in this spot is identical to what's in that one, even if they're much larger equations. You'll notice that with the hypothetical syllogism, it's fairly easy to spot because all of your statements are conditionals. Two conditional premises leading to a conditional conclusion. And much like in categorical logic that we looked at before, you have a middle term that allows you to unite the other two in the conclusion. The difference, of course, is that in categorical logic, there are four different configurations as to how the middle term could go, whereas in the hypothetical syllogism, it is stuck in that specific configuration. You can't put it anywhere else, so it has to be in that specific configuration. So that's the hypothetical syllogism. And the last of the valid forms they teach you here is called the disjunctive syllogism. Which you can abbreviate as DS. And that would take the form of A or B, not A, therefore B. Or if you preferred square or circle, not square, therefore circle. The disjunctive syllogism, it should be pretty obvious why that one is valid. You're given two options. It's either A or B. If we are denying that it's the one, there's only one option left. It has to be B. Again, this could be much larger equations, but if we have two options, whatever they are presented, and we deny one, it has to be the other one. Incidentally, even though this is the way that it's shown in the book and is typically demonstrated, it could just as easily imply this in the same way. So again, with the wedges, the order doesn't matter. It's only conditional where order matters. So maybe it's square or circle. It's not the square, or the circle, so it has to be the square. The point is, there are two options. It's not one. It has to be the other. That's the form for a disjunctive syllogism. So those six forms are always valid. Modus Ponens, Modus Tollens, Constructive Dilemma, Destructive Dilemma, Disjunctive Syllogism, and Hypothetical Syllogism. So have those written out next to you so that you can make reference to them as you need to with 6.6. But more importantly, hold them with you for next week's class when we look into Chapter 7. So those are the valid forms. There are two invalid forms that you're introduced to here as well, so we'll need to look at those. All right, so in terms of the invalid forms, these are really the opposites of Modus Ponens and Modus Tollens, which is, where they end up being the fallacies, whereas the Modus Ponens and Modus Tollens are the valid forms. So we have what's called the fallacy of affirming the consequent and the fallacy of denying the antecedent. So the fallacy of affirming the consequent, which you can abbreviate as AC, is the opposite of Modus Ponens. Okay, remember Modus Ponens, you have the form if A, then B, A, therefore B. The fallacy of affirming the consequent takes the form if A, then B, B, therefore A. Or if square, then circle, circle, therefore square. Okay, so the fallacy of affirming the consequent is basically the opposite of Modus Ponens. Modus Ponens works because the conditional says if the antecedent is true, the consequent must follow from it. I've just asserted that the antecedent is true, therefore the consequent has to follow from it as being true as well. But with the fallacy of affirming the consequent, we're doing the opposite of that. We're saying that because the consequent is true, that the antecedent must be. And of course, the conditional statement doesn't work that way. Again, we go back to the same old example. If I release the marker, then it falls. I release it, therefore it falls. However, just because a marker falls doesn't mean that I released it. There's lots of reasons why it could fall. Just like in that example we had about if Washington was beheaded, then he died. Of course, if Washington gets beheaded, he's going to die just like anybody else does. But just because he died doesn't necessarily mean that he was beheaded. There's lots of ways that a person could die. So that's why this is the invalid form, the fallacy of affirming the consequent, the direct opposite of Modus Ponens. So you'll notice basically what's happening here is that the second premise and the conclusion from the valid form to the invalid form are just flipped. The other invalid form is the opposite of Modus Tollens. And this is called the fallacy of denying the antecedent. Or DA for abbreviation. So remember again, Modus Tollens takes the form if A, then B, not B, therefore not A. Whereas the fallacy of denying the antecedent would be if A, then B, not A, therefore not B, or if square, then circle, not square, therefore not circle. Again, remember with the Modus Tollens form, if the antecedent is true, the consequent must follow from it. The consequent didn't happen, which means that the antecedent didn't happen. If I release the marker, then it's going to fall. The marker didn't fall. Well, if a marker didn't fall, then obviously I didn't release it. That's valid. But if we reverse that, and again, it's basically taking the second premise and the conclusion and flipping them, we find a very different situation. If I release the marker, then it falls. I didn't release the marker, therefore it didn't fall? Well, no, not necessarily. Because again, there are lots of reasons why a marker could fall besides my releasing it. So just because I didn't release it doesn't necessarily mean that it didn't fall. It could have fallen for some other reason. Okay, So this structure of denying the antecedent is always invalid, whereas the Modus Tollens form, its opposite, is always valid. All right. So now you have those basic argument forms presented to you, 6 valid forms, 2 invalid forms. And you can start to recognize now in some instances that there are arguments that we can know simply by looking at the form or the structure without having to worry about anything else. So let me put just a few examples up here to play with. Okay, so there's 2 I can fit on the board at this point. And so very simply, if we look at it, we have the first one, if A or B, then C or D, not A or B, therefore not C or D. So I want to know, is this one of these forms? What can we do here? Well, the antecedent, and if you're going to use the squares and circles technique, you always start with your first premise here, and the antecedent gets the square, the consequent gets the circle. So anywhere you see A or B, you can put a square around it. Now you'll notice that here it's A or B, here it's not A or B. So when you apply that square, make sure the negation is outside of it because that's not part of the original statement. So here you've got square, here you've got not square. And likewise here you've got C or D, down here you've got not C or D. So let's make sure that that circle is only around the C or D. Again, what you're using for square and circle has to be identical. So what's our basic form? If square, then circle, not square, therefore not circle. And that would be the fallacy of denying the antecedent, which we know to be an invalid argument form. Okay. Number 2, we have A or B if and only if F, not A, therefore B if and only if F. So looking again at our first line here, we've got A is the square, B if and only if F is the circle. Anywhere we see an A, we can put a square around it. Again, make sure that since that's not A, that you're not including the negation in this. The A is, you're always going by what's presented up here. So the A is the square. And then B if and only if F is the circle, and there it is again. So if we look at that basic form, if square or circle, not square, therefore circle, well, that looks like a disjunctive syllogism, which is a valid argument form. Okay, so it's pretty straightforward, pretty easy in that respect too. All right. Couple of things that you may need to know simply because in the homeworks they try to trick you. First of all, suppose that you have an argument form that looks like this. Looking at that initially, it doesn't look like it matches one of those forms. But the order of the premises don't really matter. So if you switch these around, okay, then you should be able to fairly easily recognize this as a Modus Ponens valid form. Okay, so don't let them fool you by having it written in an odd way like that. Just go ahead and flip them so that it matches the proper form, and you'll be able to see that it is that valid form of modus ponens in that respect. Okay. The other thing where they try to trick you is through the use of something they didn't actually teach you yet, but I'm going to right now, and this is what's called double negation. Okay, double negation. Basically, A is exactly the same as not A. Think about it. If you're looking at a truth table, A is true. We negate the A, it becomes false. What happens if you negate it again? Well, the false becomes true. So A and not A are exactly the same. That's double negation. And in a couple of the, at least one, I think a couple of the ones they give you, you might actually have to use that. So let's look at an example where that might be necessary. Okay. So let's say we have this presented to us. Not A, then not B. B, therefore A. Well, looking at this, I can see that my antecedent is not A, so that would get the square, and my consequence is not B, that would get the circle. But looking down below, I don't have a not B to put a circle around. I just have B. But B is exactly the same as not B. So by changing it to double negation, now I have the not B to put the circle around. There's still the other negation on the outside, right? Because the circles have to be identical. And the same thing we can do here with the A, right? I don't have a not A, I've only got an A. But if I use double negation, A becomes not A. The square is not A, right? With the negation on the outside. So now I have if square then circle, therefore not square. And so this one is going to be recognized then as a modus tollens, which of course is valid. Okay. So that's really all there is to that. And so if we take a look at, well, around page 375, there's a nice summary of all 8 of these forms that we just talked about. But then around page 379, you have exercise 6.6, which is going to give you the opportunity to practice some of these. Now, what it asks you to do is just to determine what whether it matches one of the forms or not. Now, for this exercise, only if it doesn't match one of the forms, then you're just going to say that it's invalid. Normally, you'd have to go on and work out a truth table or use some other method to test validity. But for this exercise, it tells you if it doesn't match one of the named forms that we looked at, just go ahead and call it invalid for the purposes of this exercise. Yeah, so, but otherwise, you're just going to determine what form it is and whether that makes it valid or invalid. So at 6.6 then, let's have you do, let's do 2 through 20 even. Okay. So you got a fair amount of homework actually. This is probably the biggest week for it, unfortunately, but this way, hopefully we can make sure that you are on the right track and knowing what you're doing. So let me reiterate once again, and of course it'll be up on Blackboard too. but it's 6.1, you're doing 2 through 20 even. 6.2, section 3, you're going to do 1 through 25 odd. 6.4, section 2, you're going to do 1 through 10. And at 6.6, you're going to do 2 through 20 even. Okay. If you have any questions or concerns, by all means, shoot me an email and I will get back to you as soon as I can on that. And we will meet up live on Wednesday to go through the homework, to take on any questions or concerns that you might have at that time. So if you want to let me know ahead of time as well, what questions you may have, then maybe I can incorporate that a little more clearly into what we do on Wednesday morning. All right, so I guess that'll do it for Chapter 6, and have fun, and we'll see you next time.